Okay, so why use a division algorithm? It's a simple method to convert integers to different number bases, and the standard number base we use is 10. This is the place values to the numbers of powers of 10, and it's called the decimal system for us. So if you think about it, you've got 10 to the 0, 10 to the 1, 10 squared. You've got units, tens, hundreds, and thousands, and so forth. A number can be expressed and converted in a different number system using any integer as a number base, and we're going to look at that. But the three most useful ones are 2, 8, and 16, because you've got binary, octal, and hexadecimal that are used in computing and electronics. So we are going to look at those and converting other things as well. So if you have a number, let's say 25367, and it's base 10, then you would use base 10 where you have the power 0, 1, 2, 3, and 4. That means you'd have 2 times 10 to the 4, 5 times 10 to the 3, and 3 times 10 to the 12, and so forth. You can do it left to right or left to right to left, but I'm just showing you by using the blue digits that we've got the number there. So that's 2 times 10,000, 5 times 1,000, and quite quickly you can get the number. Whatever the base was there, this will be the answer in base 10. So it's just to show you the process just now. So if I said to you, convert it to base 10, now it's silly because it is base 10 already, but I'm just showing you the process, then we'll use the division algorithm to do this. So how many 10s are in that? You've got 2, 5, 3, 6, and 7 left over. Then you've still got 2, 5, 3, 6 to use, so bring that over, and how many 10s are in that? And you've got 6 left over. You're still dividing through by 10, so now you've got 2, 5, 3, you've got 25 and 3 left over, and you keep going, and you've got 2 with 5 left over, and then bring down the 2, and you've got none at all with 2 left over. As soon as you get to 0 times anything, that's you finished, and this is the final calculation. Okay, so what we do next is we go from bottom to top, and we look at your remainder parts, and we get 2, 5, 3, 6, 7, and in fact that's your number. We would never normally start with base 10 and end in base 10, but it's to show you the process. Okay, so let's go to binary. In decimal, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In binary, you've only got 2 zeros and ones, which is used in computing programming. So the binary number is 11010. You may see it written with a little 2 there. Okay. What would we do first? We would write down the number, and because it's base 2, we'll do 2 to the 0, 2 to the 1. Okay. So whatever the base is, that goes here. That means it's 2 to the 4 times 1, 2 to the 3 times 1, and so forth. So it's 1 times 16, 1 times 8, and so forth. Click together your numbers and find your answer. That means that's in base 10. So that means that you've got 26 to the base 10. So if you were asked to put that base 2 into base 10, that would be your answer and you'd have finished. But I'm going to show you how you can do base 10 back to base 2 now. So if you do base 10 back to base 2, you start with a number, and then you see how many 2's go into it, and you've got none left over, and then you've still got 13, so how many 2's are in it? And you've got 1 left over, so now you've still got 6. How many 2's are in it? None left over. You've still got 3. How many 2's are in it? 1 left over, and you've still got 1, so how many 1's are in it? None, and then 1 left over. Remember, we read from the bottom to the top, so we are going to go 11010, and in fact, there you go, it's the exact same as what we started with. So let's try it without going backwards and forwards in a loop. 30 to the base 2, 15 with none left over. You've still got 15 to deal with. 7 with 1 left over. You've still got 7 to deal with. 3 with 1 left over. You've still got 3 to deal with. You've got 1 with 1 left over, and 1, you've got none with 1 left over. It's not plain ball, is it? Okay. What have we got there? We've got 11110 to the base 2. You can do it with octal as well. The difference is it's 0, 1, 2, 3, 4, 5, 6, 7. So this time use a calculator, and if you divide by 8, how many 8s are in that? What you'll find is there's 3 ways to do this. So we have method 1. You can divide by 8 and get this in your calculator, so you know there's 6683. And then after that, what you can do is clear your screen and then do 5, 3, 4, 6, 7, take 8 of those. When you do that, you're left with 3. The alternative, which I'm more popular with, is doing division again, so you get the same answer, but instead take off the 6683 once you wrote it down, and you're left with the decimal part, and then times it by 8 and you'll get your remainder. Or you can use the fraction button, but remember you'll have mixed fractions, so you'll need to use the above del, the SD button. To use mixed fractions, you might need to use shift, and you might not always get it as parts of 8, so that's what scares me about that if you make a mistake. Okay, so just be careful if you go by the fraction route. Right, do the same again, bring down 6683, see how many 8s are in it, and then you can take the 835 off and then times by 8 and get your answer. Bring the 835, you get 104, and you've got 3 left over. Bring down 104, you've got 13, and you've got exactly that. You've got no left over. 0 left over, and then bring down the 13, you've got 1, 5 left over, and bring down the 1, and 8 doesn't go into 1, and then remember to bring that over. And then after that, bottom to top, 150333, and there's your answer. You could go back and check it by putting 8 to the 0, 8 to the 1, and so forth. You don't have to, but it's just to let you know you could go and check it. Right, hexadecimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but what happens after that? So if you think about it, you're only allowed one space to represent each digit, so 10 can't be represented by one digit, so we call it A, B, C, and D, and so forth. Okay. So let's use the calculator and do 298047 divided by 16, and we get this answer out. So we'll put 18627 in. Take off the 18627, and then you're left with 0.9375, and re-times it by 16, and you'll find out what you've got left. Bring down the 18627, divide it by 16, you get 1164. Take off the 1164 in your calculator just now, you're left with the decimal, times it by 16, and you're left with your answer. Keep doing that, bring down the 1164, divide it by 16, find out what that is, and then take off your answer, times it by 16, and then keep doing the same. How many? That would give you 64, you'd have 8 left over, and then you can't get any out of 4, and you've got 4 still left over. What's the difference here? You're only allowed a digit per number. This should be working. Okay, so how do we deal with this? So you're still going to read it from this bottom to top. A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So it's 4, 8, C, 3, F. Okay. Exam style questions might not ask you from a decimal system into a different base. It might actually start from a different base. So you've started with base 10 and changed to these, but the extension is you don't start with base 10. So let's say we start with base 7 and go to base 3. We go through the process of using base 7, get it to base 10, and then finally deal with the division algorithm in the base 3. So let's do it. So base 7 to start with, we go 70, 71, 72. That'll be 2 times 49, 3 times 7, and so forth. Okay. Get your answers, and of course you're allowed to calculator. So if it starts with a different base, we do this first, and then your answers in base 10. Now what we'll do is use the 1, 2, 3 in base 10 and change to base 3. So that's the division algorithm. Bring down the 41. 3 13s are 39. Bring down the 13. Oh, sorry there. I'm not going backwards, so I'm just doing this 4 times. And then 4 times 1. And then bring down the 1. What would that mean? It means 11120. Okay. Base 5 to base 2. So you start at base 5, do that. That'll be 1 times 5 to the 3, 1 times 5 to 1 times 1 to 5, and so forth. Collect your answers. So you start with whatever the base is, and that way what your answer is base 10, and then you change it to base 2. So how many 2's are in it? What's your remainder? Bring down the 75, how many 2's are in it? What's your remainder? Bring down the 37, how many 2's are in it? What's your remainder? Bring down the 18, how many 2's? What's your remainder? Bring down the 9. That goes 4, what's your remainder? Bring down the 4, goes twice, no remainder. Bring down the 2, goes once, and then bring down the 1. This worked perfectly before, it's just the way life is. Okay? 1 0 0 1 0 1 1 1. There we go. Okay? Now you're going to try. So you go base, change it to base 10, and then deal with what you're trying to change it to. You'll find questions on page 193 if you want to look at the book. There's the questions there anyway, and I've put extra ones in there for you to try. Okay? These ones, the answers in 260. These ones, the answers are in the next page in the PDF.